Hey guys, alright, we're going to have a very short video over pH here. So we'll just talk about this. I'm going to assume that you guys have all heard of pH before at some point, hopefully like back in middle school, but we'll actually dive into like more of what the pH scale means and how it actually works here. So first thing that you need to know about pH is it's actually a math formula. So to measure acids and bases, we use the pH scale, but P, that lowercase p in math, means negative log. So pH is actually the negative log of H plus concentration. So in water, that scale is 0 to 14. Um, so pH technically means negative log of H plus, and then POH, which we'll also talk about, is negative log of OH concentration. So um, basically, one measures acids, one measures bases. Um, Now, how to do the negative log, you might need to like find that on your calculator a little bit, but depending on the type of calculator, the negative button is there. And I have the negative and log buttons circled on different types of calculators, so you kind of know where to find them. But um, that just kind of helps. So just you'll end up using the negative log quite a lot. So get used to those two buttons for this. So here's the general pH scale. Um, so the top is the pH scale. So 0 to 14, acids are 0, bases are 14 over here, and then pure water is neutral. The POH scale is just the flip reverse of that. So it also goes from 0 to 14. It's just that now acids are 14 and bases are now 0. So they're inverses of each other. And so kind of looking at what that looks like in terms of concentrations, on the pH scale, if you have a concentration of 1, um, then that is an acid. That acid has a pH of 0. If the H plus concentration is 1 times 10 to the negative 7th, that gives you a 7, which is water. And then bases, really strong bases, have an H plus concentration of 1 times 10 to the negative 14th. OH is again just the flip of that. So strong bases that have a OH concentration of 1 have a POH of 0, and then it flips the other direction. So how to actually calculate pH? Well, I keep telling you it's the negative log, so you can go back and forth. So if you know the value, if you know the concentration of H plus, so that's where all that molarity stuff comes in, um, then you can just follow this. So this arrow right here is this equation right here. So the pH is equal to the negative log of H plus. And then going the other way, if you know the pH and you want to know what the H plus concentration is, you go 10 to the negative exponent of pH. So take whatever value this is, do 10 to the negative power of this, and that will get you back here. Um, and then we can do the exact same thing with OH and POH. So again, if we know what the OH concentration is, negative log of this will give us POH. And if we go the other way, if we know what the POH is, we can take 10 to the negative POH to get to OH. So that gets us back and forth. So this whole thing we call the pH square just because it tells us how to get back and forth between stuff. So we know how to go back and forth between H plus and pH. We know how to go back and forth between OH negative and POH. So we can do these. Now how to do these side ones kind of give us the full circle. So this one is probably the easiest. If you know what the pH is and you know what the POH is, these have to add up to 14. So if you know what pH is and you want to go to POH, you just take 14 minus the pH, and that will give us the POH. That will follow this way. And then going the other way, if we know what the POH is, again, 14 minus this value will equal pH and take us to pH. So that's how we get back and forth here. So you know how to go from H plus to pH, you know how to go to OH and POH, and between pH and POH. This one right here is a little bit more complicated. Um, so like I said, this is a little bit more complicated. So you see this KW factor right here. So on the next slide, I'll kind of show you what that looks like a little bit. So KW is equal to this value, 1 times 10 to the negative 14. So it's a constant. So these are the two back and forths that you see here. So solving for H plus and solving for OH minus. Um, so to solve for H plus, if you know OH minus, you just take this KW constant, plug it in here, and divide it by whatever OH minus is to get you here. Or to go from H plus to OH minus, again, it's the same division, it's the same idea, you just do a division. So KW divided by H plus gets you OH minus. So that takes you around the whole square. So once you know that, if you start in any corner here, you can go around this entire square and you should be able to solve the other three. So you just need to know a starting point like H plus. So if you can find the concentration of H plus, then you can find pH, then POH, then OH minus, or you can go this way and do OH minus, then POH, then pH. It doesn't matter what direction you go. Because it's a square. You can start in one corner and work your way around in either direction. So let's kind of look at an example of what that looks like. So here we want to know what the pH is of an NaOH solution that has a concentration of 3.2 times 10 to the negative 6th. So we have sodium hydroxide, so we have this OH here. So that means that we are probably going to be able to start here. We can start with concentration of OH, and we need to get to the opposite corner to get to pH. So we can either go up and around, so we can go from OH to H plus and then pH, or we can go from OH to POH and pH. I personally think this route is easier, so I think that's the one that I ended up doing. But let's look at what we know. So when NaOH breaks up, we get Na plus and OH, so we get this one OH. So that means that the concentration of this whole thing is the concentration of OH. So since there's one OH that breaks off, for every one of these, that means that there's 3.2 times 10 to the negative 6th of these things in this solution. So that gives us our starting concentration. So again, just bouncing back to be clear, now we know what this value is, so now we can go this way around or this way around. So from there, we need to, I took that to POH. So here's the OH concentration. I took the negative log of OH to get POH, and that is equal to 5.495. And you'll notice there's no unit for this value. So concentration has a unit, pH has no unit, KW has no unit. They're all unitless values. And then once I got the POH, so again, that brings me here. So I went from here to here, and now I need to get to pH for this problem. So to do that, I just take 14 minus the POH, gets me pH, which is 8.505. And there's our final answer. So this is what we were looking for this problem. So basically, at this point, like it's basically just practicing going around the square and getting used to it. So I have this grid here set up for you where I give you starting information of one corner, and you have to so you're starting here at H plus, and then you have to figure out what OH minus is, pH, and POH. Again, you can go any direction around. You just need to solve all three of these. And then you do the same thing here, same thing here, same thing here, etc. Here, the only difference is I'm giving you an entire chemical, so you have to figure out where you're starting on this square, and then go from there. So I would strongly suggest that you guys pause the video right now. Go try, see if you can't solve these things out, and then I will throw the answers up here in a second. So again, try to solve some of these and then double check before you see the answers. That's the general idea here, but so pause it and then see what you guys can do. So I'll throw the answers up here in 5, 4, 3, 2, 1, and there's your answers. So hopefully you guys got these same answers. Also, hopefully I didn't make a mistake in any of these, but um, that's what you should get for everything. So the green values are the ones you didn't have before. Um, so you can double check yourselves. Let us know if you have any problems. There's the discussion board and everything. This should be pretty straightforward, but sometimes people just get a little confused on exactly what they're doing with that square and how to do the equations. So definitely let us know if you're having that problem. If you would like more practice, there's this website right here. So ScienceGeek, just this tiny URL, has some more practice using the exact same pH square thing. So it's a good chance for that. So anyways, I hope you found this pretty straightforward and easy to pick up. And let us know if you have any problems beyond that. I hope you guys have a lovely rest of your day.